Okay guys, we are back with the second page of the review here, moving on to hyperbolas, and we need to identify the center, vertices, foci, and asymptotes. We'll be going through all of that. So first of all, the center here is a little tricky. It's kind of the same thing we've been doing, but you have to be careful. You have to go to the x numerator, like where your x's are, and you have to use that for your h value. So remember, it's h comma k. So this center is going to be located at 1, -2. So that's the thing that students make mistakes on. So just be careful with that. And for this one, we are going to move 6 up and 6 down. I'm going to take the square root of 36 and get 6. The square root of 9 is 3. So I'm going to move 6 up and down. So we'll call A 6 here, and B is going to be 3 here. And this hyperbola is going to be opening in the direction of your y, which means up and down. Y movements are up and down. So remember, this is going to open up and down because y is your positive, or y is your first numerator here. So it's going to look something like this, and it's kind of good if you can start just by thinking about what you're doing. So this is going to be a hyperbola that is a vertical hyperbola because it opens up and down. Okay, so we have our center, 1, -2, so let's go and sketch that in place. We know we're going 6 up and 6 down. We're going 3 to the right and 3 to the left. Now, I want to point something out. At this point, it's kind of like we just did an ellipse, but we're not. We have to put our corners in place. Think about this as a rectangle that's going to guide the shape of our hyperbola. And I can go ahead and put my asymptotes in place right here. I'm just kind of doing this, not very technical about this, just kind of sketching your asymptotes in place. And it goes through the corners and the center every time. And I haven't even had to think about really where I'm going to put the graph, but we talked about it. This is going to open up and down. So I'm going to start with the vertex here and kind of make it approach the asymptotes. Same thing down here. And these are not specific points. They're just kind of approximations of us starting at the vertex and kind of going out, approaching the asymptote there. Okay, so that is what that looks like. And we need to find our vertices. So remember, the vertices are where your curve actually extends. So that's when I went up 6. So I'm going to take my center, 1, -2, and I'm going to say the -2, I'm going to go up and down the value of 6. Okay, and I don't need to find the co-vertices on these. These are not as important, but if I did, I'd just be adding to this 1. I would add 3 and subtract 3. So the foci here, I need to find C. So C is going to be the sum of the two denominators. So this is a little bit different than the ellipse, obviously. Okay, that's going to give me the square root of 45. So remember that for the foci, for the hyperbola, they are inside the curve, which means I've got to go past this movement up by 6. I've got to go a little bit further. Well, the square root of 45 is just barely inside that. Okay, it's between the square root of 36 and the square root of 49. So it's going to be a little bit closer to 7. So I'm going to be really close, like right there and right there. But it doesn't really matter. I know I'm just going to say 1, -2 plus and minus that square root of 45. And you can leave it just like that. So that's the foci. The only other thing we need is the asymptote. And I'm going to show you, obviously it's y minus your k value is equal to plus and minus m, and then x minus your h value. So it's like that. So y minus k is going to be y minus a -2, or y plus 2. Well, a neat thing happens. Look up here. Do you notice that that's the same thing? So if you simply start by writing your y numerator, and remember it's not squared, this is a line, but it is the y plus 2 inside here. And this is also what we're going to use over here, x minus 1, because if I did x minus this 1, it matches. So real quick, you can just look at this and this inside the parentheses, and that's going to give you how you write your asymptotes. Now, I do need rise and I do need run. So I do rise of 6, run of 3. So 6 over 3. And it's both directions because it's 6 up and 3 to the right, 6 up and 3 to the left. So this would be your negative slope right there. And that's perfectly fine. You could simplify that down to a 2, but that is perfectly fine. So if you want to mark that out and do a 2, you can do that. All right, so that is just a basic graphing for the hyperbola. Now let's look at one that is not given in the conic graphing form. So I see that I have an x squared and a y squared. So I know it's not a parabola. And I see that 9 is positive and negative 16 obviously is negative. So not the same sign. So it has to be a hyperbola. I do want to see if maybe I can simplify this down a little bit. So I know I can definitely divide by everything by 2. Could I divide by something bigger? Let's see. I think I could definitely divide by 4. No, I can't because of this 9 right here. Okay, so I think we may just have to, we can't divide by 2 either. Sorry, I misspoke. I didn't see the 9. So let's just start where we are and group things together. So I am going to basically take this 9, I'm going to rewrite it, 9x squared minus 36x, leave a little bit of space, and then I'm going to say negative 16y squared minus 96y equals, and I'm going to subtract 36 from both sides. So I'm ready to get started. So I'm going to factor out the 9, and that leaves me with x squared, and then 36 divided by 9 is going to be a minus 4x there. So half of negative 4 is negative 2 squared is 4. Did I really add 4? No, I really added 36. So I'm going to add a 36 here because 9 times 4 is 36. Then continuing on, I'm going to pull out the negative 16, and that's going to leave me with a 6 inside the parentheses, so it would be y squared. Now, this sign is going to change. Look at the mistake I made right there. That should be a plus. Okay, so sorry about that. That should be a plus. No, it shouldn't. I'm so sorry. That should still be what that is right there. So this should have been a negative like I did, but this one will change signs because I'm factoring out a negative. So it's going to be y squared plus 6y for this. So sorry I confused you on that. Okay, so half of this is 3, and I square the 3, and I get a 9. But did I really add 9? No. Ironically, I am actually subtracting something here. I'm actually subtracting 144 over here. Okay, so let's write all this out down here. So I have a 9. I have x minus 2, so same thing, just always half of this b value. And then I have my negative 16, and then I have y plus 3. And all that is equal to, it's going to be a negative 144. Okay, so this is kind of an interesting problem here. So remember the last step is going to be to divide both sides by negative 144. So I'm going to divide this by negative 144 here, negative 144 here, and negative 144 here. Now this has an interesting little outcome. When I divide this negative by this negative, it actually changes this to the positive term. So it's going to come out front. Okay, so this is going to simplify down 1, and then I'm essentially just dividing 144 by 16. So it's going to simplify down to a 9. So y plus 3, and remember this is positive now, so y plus 3 squared is going to be over 9. Now this one is going to be the negative one. And when I divide both of these by 9, I'm going to get a 16 here. And then this is x minus 2. All squared is equal to 1. So this is the equation that we're dealing with. Okay, now what made that one hard is the fact that at the end you had to divide by a negative on the right side. And what that does over here is what you thought was the negative coefficient becomes the positive coefficient. So just be careful with ones like that. Maybe go back and try it again on your own from start to finish. Okay, now the center for this one is going to be 2, -3. I'm going to go 3 up and 3 down, 4 right and 4 left. But this is going to open up and down. This is going to be a vertical. Okay, so let me go to 2, -3. And then I'm going to go 3 up, 3 down. So those will be my vertices. I'm going to go 4 to the right and 4 to the left. And then I'm going to put my little corners in place. And again, just sketch my asymptote there and here. And because it opens up and down, I'm just going to kind of make it do like this. Approaching that, same thing down here. Okay, so my center 2, -3, my vertices are going to be, when I go from the center, I go up 3 and down 3. So it's going to be 2 and then -3 plus and minus 3. So I'm just taking my center and going up and down 3, and you can leave it just like that. The foci, I need C, of course, and that's just going to be 16 plus 9, so it's going to be square root of 25, which of course is just 5. So inside, so I'm going up 5 and down 5. So my foci are going to be 2, -3 plus and minus 5. And it's fine if you leave it just like that. So we have our center, we have our vertices, our foci, and the asymptotes are going to be easy because remember we're just going to go here and do y plus 3 is equal to plus and minus, and then I'm going to do x minus 2 here. And then my rise was 3 and my run was 4, so I'm just going to write that right there. So here's kind of all my information, center, vertices, foci, and my asymptotes. Okay, and that's pretty much all we need to do for that one. All right, so moving on. Write an equation for the hyperbola graph at the right, and I know my center is -4, 0, and it opens up and down. So we've had a lot of up and down vertical ones here, but I know that I'm going to have y first, so y minus 0 squared, and then I have minus x plus 4 squared. So see, if I was graphing this, this would be a -4, 0, which is what I have for the center. Now, to get to, apparently this is supposed to be the covertex. So this is your left-right movement, so it's going to go right here underneath this denominator for this denominator of x. So if I'm going from -4 over to 1, that distance is 5 because I have to go -4 to 0 and then 1 more. So this is going to be 25. Now, I don't know this distance. It's not telling me that. But I can find C. So let's find C. So I'm going from -4, 0 up to -4, 6. So I'm going up by 6. So C is 6. So what I'm going to do is use my formula, which says C is equal to A squared plus B squared. So I know C is 6. And I know that one of my denominators is 25. So 25 plus, and it doesn't really matter what you call this one. Let's just call it A squared there. So to solve for this, I'm going to square both sides to get rid of this square root symbol. So I end up with 36 is equal to 25 plus A squared. So 36 is equal to 25 plus A squared. So if I subtract 25 from both sides, I'm going to end up with an A squared of 11. So this denominator will be 11 right here. So there is our equation for that. So that was a little extra little thing we had to do at the end because we didn't actually have our B value. Well, we had our A value, we didn't have our B value, but we could use C to find our unknown. So that's how we're going to approach ones like that. Okay, now we're moving on to parabolas. And So we have this situation here where we're going to first identify how it opens. So it's x equals y squared, which means it's going to either open left or right. Because this is a positive, it's going to open to the right. So kind of think about what that's going to look like. And the center here, or the vertex I should say, is going to be 4, -3. Again, be careful. This will always give you your y movement. Whatever's with your y will give you your y movement. Over here, this will give you your x movement. So my vertex here is going to be a 4, -3. And remember, you always change the signs inside the parentheses. Okay, so 4, -3, and this is going to open to the right. And I need to find my p-value. Okay, so p is equal to 1 over 4a. And so here I know p is equal to 1 over 4 times 1/4. 1 over, and this is going to simplify down to 1 over 1, so p is just a 1. So I'm going to go inside by 1 to find the focus point. So going back to my vertex, I'm going to have 4, add the 1 to that, so the focus is just going to be 5, -3. And then directrix is going to be 1 in the other direction. It's going to be like this. So it's going to be located at x equals 3. And that's going to be your directrix. Okay, so now the only other thing we need is we need to kind of guide the shape of this. And the focal, this is called your focal length right here of 1. Your focal width, though, is always 4 times that amount. So I need to go up 2 and down 2 to kind of guide the shape of this parabola. And there you go. So that's what we needed to do for that one. Okay, so the next one is going to open down because it's y is equal to x squared, and that's a negative. So the vertex is going to be located at 4, -2. Remember, change the sign in here. Keep the sign outside. And so let's go to 4, -2. And I know it opens down. I need my p-value. So p is 1 over 4a, and then our a here is a -1. So it's a -1/4. So again, it tells us to go down by 1/4, so barely at all, okay? And then I'm going to use that, and I'm going to subtract that from my y. So that will give us our focus point. Our focus is going to be 4, and then I'm going to do -2, and I'm going to do -1/4, which just basically makes it a -2 and 1/4. So it's a little bit lower than -2. And then our directrix is going to be in the other direction. Remember, this is going to open down like this in just a minute. So it's barely going to be above this. So I'm going to take this -2 and I'm going to go up by 1/4. So that's going to leave me at y equals -1 3/4. Okay, so and you're going to have your calculator, so you can do that in the calculator to kind of help you out with that as well. So the only other thing we need to do is graph it, and I know p is 1/4 down. That means if I multiply that by 4, I'm just going to get a focal width, and I'm going to say 4 times 1/4 is just going to be a 1. It's a really, really tiny little movement. Remember, the focal width will go from the focus point, so it's really skinny. So that is what that one looks like. Okay, almost done. Write an equation for the parabola graphed at the right. First of all, because it opens to the right, we know it's going to be an x equals y squared parabola. Okay, so I'm going to need to take the center and go ahead and plug in what I know about that. Okay, so x is equal to, my center is 3, 6. So I'm going to leave a space for my a value there. Okay, but it's going to be y, and change the sign of this y. So it's going to be y minus 6, all squared. And then this is a positive 3, so just put a positive 3. Okay, so 3, 6. So if you were graphing it, you would know to keep that sign, change that sign. And then x is equal to 1, meaning this distance here is 2. So x of 1 moving over to x of 3, this distance must be 2. That means p is 2. So p is equal to 1 over 4a, also a is equal to 1 over 4p. So when I fill this in, I get 1/8. And because it opens to the right, it is going to be a positive. So 1/8 is your, the only other information you need is your a value. So that is that equation of that parabola. Okay, so you have all this. Maybe print out an extra copy of the review, try reworking it, highlight the ones that you're having trouble with, go back and watch that part of the video. And I think that will really help you guys, and I hope it goes well. So good luck and study hard.